Hello YouTubers and fellow hams. Well, let's build a magnetic loop. Back in March of 2023, just before my illness became horrible, I did a video where I designed a magnetic loop, and I walked you through the process that I go through to design a magnetic loop. That video will be linked up here somewhere. If you have not watched it, you should go watch it first, because this video is based on that video. So if you don't watch that one, yeah, you can still get something out of this, but it won't be the same experience. Anyway, these are the specs we came up with for my magnetic loop. I wanted a smaller one that might be a little bit lighter so I could carry it pedestrian mobile. And we targeted 20 meters through 10 meters. And this is what we came up with. So we got a circumference of 6.2 feet or 1.9 meters, which gives us a diameter of 2 feet or 0.6 meters. The coupling loop is 1/5 of the main loop size. That's sort of a general rule of thumb. So we calculate that out at 4.8 inches diameter or 12.1 centimeters. And we had a variable capacitor of 33 picofarads to 150 picofarads. That was our target. Now I went ahead and got my parts all together. So let's go take a look at the parts. I'm ready to start putting together that magnetic loop. I've got a bunch of parts. For the spine, or the backbone of it, I'm using a piece of plastic pipe. This is PVC pipe, 3/4 inch here in the US, but you could use whatever you want. All right, let me turn that off. You could use whatever you want. That's all up to you. I have some coax that'll feed the loop. It's already got BNC ends on it. Yeah, I'm cheap on that. But I'll cut the other end off, and this will go up through the pipe to feed the coupling loop. I have coax that will form the actual loop itself. I don't know what this is. There's no label on it. Doesn't really matter. It's nice and heavy. It sort of holds its shape pretty well. The ends I will be shorting in the where the capacitor is, so I'll be using the entire coax as a single conductor. The shield and the center will be used together. You want the outer loop to have the lowest possible DC resistance. That makes the whole thing more efficient. I have a capacitor. Okay, so this I found off eBay. There are many of these available on AliExpress if you don't mind waiting while they come from overseas on a shipping container. But I got lucky and found one on eBay that matches the specs that I need for the loop. I've 3D printed this little thing that it's going to mount on the pole with for now. Ultimately, I'm going to put it inside of an experimenter's box to protect it from dust and debris. This is just a quick and dirty solution to try it out. And you can kind of see in here, I've got a picture of these separately, but I shorted the shield to the center here on the connector so that outer loop will be one conductor. I 3D printed a piece for the headstock. This will go at the top of the pipe. And then there's holes here for zip ties to go through to zip tie the coax onto here and the coupling loop as well. I'm going to redo this. I made it too thick. It doesn't have to be as thick as it is. It's plenty strong, so I'm going to redo this before I put the part up on Thingiverse, but it'll be available. You could cut something out of a plastic cutting board. You can get those for less than $1 at your big box grocery store. That cheap little thin plastic cutting boards, that's great material for making stuff out of. You can cut stuff out of that for this, but that's what I'm going to use. So, oh, and I have one other, well, yeah, some of these. Can you see them in there? They're ground lugs. I'll put up a link to where I got these from off Amazon. They're really useful. I'll put a screw through this into the pipe, and then I'll have a point to solder the coupling loop onto and the coax onto. So you'll see when we put it together. And I got a coupler. Those are basically the parts that I'm going to use to start putting this together. You might recall from the design specs that the capacitor that I needed had to have a range of 33 picofarads to 150 picofarads. This is the capacitor I got. And as you can see, the plates are unmeshed and our low is about 6 picofarads. And when the plates are fully meshed, $178. So this capacitor exceeds the range that I needed, which means we'll probably get a little bit further outside of 10 meters and below 20 meters with the loop. One additional note on this capacitor, I don't know if I've mentioned it in the video or not yet because I'm cutting this over multiple days, but the plate spacing is quite tight on this cap, so it's not going to be able to handle very high a voltage. And at 5 watts, I think we were looking at somewhere in the arena of 400 to 600 volts RF across it. So I think we'll be okay at 5 watts max with this loop, which is fine. I'm designing it for a QRP loop anyway. But you'd want to have a capacitor with much bigger plate spacing if you were going to run any more power than that. Otherwise, it'll just arc over because you'll have such high RF voltages. So yeah, the plates are pretty close on this one. I'm pretty sure I'll be okay up to 5 watts. Honestly, I probably won't run more than 2.5 watts into it anyway. So let's go ahead and put the loop together. Now, this video might be a little long. I don't know how well I can edit it down for time, but if you're a person with a short attention span, rather than whining in the comments, go watch something else. But for the rest of you, let's go put the loop together. So I'm working on putting together the magnetic loop. I have my pipe and I have placed my headstock piece on, which you can see here. This is what the coaxes are going to mount to. The coax for the outer loop, which I have here. And I know you can't see it on camera. Where is it? I can feel it. Where is it? There it is. I put a little piece of tape on here. What I did when I measured this coax out is at the center of it, I put a piece of tape so I would know exactly where to mount that on there, right there. And I'm measuring things out. So the coupling loop's diameter is 4.8 inches or 12.1 centimeters. So I'm going to figure out exactly where. We're going from there. 4.8 is about here. So I'm going to have a couple of points right there where the coupling loop is going to come to and mount up here. And then a little bit below it, I need a hole for, this is the coax. It's going to come up the middle of the pipe to attach to the coupling loop. So I have found a drill bit that is about the same diameter as the coax, and I'm going to drill the hole for it. I want a little bit of a space to wrap tape around it for strain relief. So I'm going to put a hole about 1.5 inches maybe down. Yeah, I think that's about right. I'm just doing that visually. I want enough of a gap from where the coax comes out to where it connects that I can wrap tape around it to be a strain relief. Now, I drilled my hole straight in, but I'm going to do something. Watch this. What I just did is I angled the hole this way so the coax will come out of it angled towards the point where it's going to connect to. That way the hole is not going to cut into the shield of the coax, and I'm not going to be making too sharp of a bend in the coax when it comes out of the hole. It'll go, well, I can do it. I can show you. There. So you can see how it's coming out at an angle. That way when I bend it over to tape it, I'm not putting too sharp of a bend on the coax right here where it comes out of the hole. In fact, I think I want to angle that hole just a bit further. There we go. Yeah, that's good. You can see the angle of the coax is coming out of the hole. I'm not going to put too sharp of a bend on it there, and yet that'll still provide strain relief when it's bent over. it doesn't want to move in that hole. So there you go. All right, so what's next? I need to get my coupling loop mounted. I'm going to put 2 ground lugs here for that. Drill a couple of small pilot holes. The capacitor is going to mount down here. I already measured from this point where the coax is going to be 2 feet down. And that's where the capacitor is going to connect. And I 3D printed a jig for it that'll mount here. Like so. So I got to get that mounted. So that's what I'm doing next. I got to drill some more holes, mount some more stuff, and then I'll show it to you. Okay, I am getting ready to mount the capacitor assembly here and drill the holes for it. One thing I wanted to point out, if you don't have one of these are like little finger drill. These things are cool. It's like a pen, but it holds a drill bit. And it's very, very useful for marking your start holes on things, your pilot holes. So I get that all lined up where I want it. I want it right here. I can put this little finger drill thing through here like that. And I can mark where my pilot hole should be. Yep. Made a little mark right there. Mark it with a marker, get that line back up, and I can get the front hole. Yep, right there. Easy peasy. So yeah, if you don't have one of these, get one. They are so handy. So many times I have used this, especially when I got a tight thing to work in, tight area to work in. Up here on the head of this capacitor mount where the screw hole is, down inside of here, not a lot of room to work or get a drill in there now that I've got the capacitor mounted, but with this, no problem. Okay, I am getting ready to solder connections for the loop here. Now I'm using coax for the coupling loop, and I'm doing that because it's nice and stiff and it'll maintain its shape, its nice loop shape. And I am using both the center and the shield together at the ends. I joined them up so I got the most conductor as possible. No reason to treat it like a coax. It's just being a wire at this point. And like I said, the reason I'm using the coax is because it'll maintain its shape. Holding that nice loop shape. Now I'm pre-tinning the wires on. I'm sorry if my hands are in the shot. I can't look at the camera and concentrate on this at the same time. But anyway, I'm pre-tinning the wires on the coax feeder before I make its connection. And one thing I'm doing that I wish I could show you, maybe you'll be able to tell, is I am bending the center at a right angle before I do the solder so that it doesn't melt through the dielectric. If I pulled it over and soldered it, then it would melt through the dielectric and touch the shield here, or it could, and short itself out. We don't want that. So I bend it at a right angle ahead of time. And I'm trying to do this and keep my hands out of the shot, but I know it's not working. But I make my bends all that ahead of time so that everything lines up before I start soldering, so that the heat doesn't, again, cause that dielectric to go through. I've had that happen too many a time and ended up with a shorted connection. Okay, there we go. Again, I apologize for if if I'm getting in the shot here with my hands, I am sorry about that. I'm focusing on what I'm doing and not and not the camera. And this is a little harder for me these days. One thing that a lot of people with long COVID talk about as they recover in the support forums is that they are not as sharp as they used to be. They stutter, they have memory gaps, and so on, and I'm noticing that too. And there was some research recently into the brains of people that have had long COVID. Some people that died while they had it, and it was, I think, Australian research. It's happening all over the world, the research. I try to follow it as much as I can. But brain injury. The brains were biopsied, and they observed damage to capillaries and arterial walls and so on. So it is actually brain injury, which I guess is why it takes so long to recover from. And of course, every time that I mention this, I'll get comments from heartless, uninformed individuals. Negative comments. There we go. Yeah. That's just about right. Okay, let's bend this over. Get it in the hole. And now I can solder. These are the only solder connections I have to make. The capacitor's already done. There's that in. And that in. Our loop is now functional. But I need to take some tape and do my strain relief here. And make a tripod mount for the other end, and then I can set it up and we can put it on the VNA and see if our design measures up to what we actually see in the loop. Okay. I know my desk is messy. Don't bother wasting time in the comments. I'll clean it up eventually. Here's our loop. All assembled, as you can see. And I made a tripod mount with a coupling and a plug, which I drilled a hole in for the tripod screw. So that works. Capacitor assembly. The coax is shorted here so that both the shield and the center are being used as a single conductor throughout the loop for the lowest DC resistance, highest efficiency. I strain relieved the coupling loop connection there, as I said, wrap tape around it. And we are zip tied up here. The coupling loop directly adjacent to the main loop. So now I need to put it on the VNA and let's see how our range compares to what we were expecting. Well, now that I got the loop together, the next thing I'm going to do is hook it up to the VNA, and we're going to profile it, see what its range is, and see what its SWR is on the amateur bands. Sorry for the handheld cell phone camera, but we're going to check out the loop's profile now, and we're going to see what our range is. Now remember, this capacitor was a little bit larger range than what I calculated, so we should see a broader range. I was shooting for just below 20 meters up to over 10 meters, and I keep forgetting to turn that off. And I expect we'll get further. So I've got the plates completely unmeshed. We should see the high frequency range of it. Over here, I have my mini blue VNA. Turn it on. And we'll launch its software. Frequency range. Let's go for all. That's going to be, wow, no, I'll just go for HF. HF. I don't know where it's going to be precisely. Let's see what we see. There it is. Wow. Okay, so with the plates unmeshed, we're up around 41 megahertz. Let's see precisely where we're at here. Looks like it's good and sharp. Okay, there's our low point. 41.256 megahertz is the high end of the loop. So yeah, we're well in excess of 10 meters. That's good. Okay then. All right, now let's mesh the plates fully and see where our low is. There we are. Pull my marker over here. And it looks like our low end is at 8.62 megahertz. The SWR is 2.7 though, so that's not very good. But let's make a note of that. Well, you saw from our frequency range when we profiled it that we're almost down to 40 meters. And somebody is bound to ask, how would you get it down to 40 meters? Well, the easy solution would be to simply add a longer piece of coax for the outer loop and make the outer loop a little bit bigger. If you took the outer loop to about 3 feet diameter, it would undoubtedly get down to 40 meters with the existing capacitor that we have. So that's how you would do it. Efficiency on the lower frequencies will be less, but it would work. Let's bring it up to somewhere where we could operate. 10 megahertz per se. Let's bring the plates up a little bit, run, see where we're at. Yeah, there we go. 10.133 megahertz. We're seeing an SWR of 1.09 to 1. Okay, there we go. Inside the band, we're seeing 1.55 to 1 in 20 meters. That's not too bad. Okay. 17 meters. We're just within the band there, but our SWR is 1.55 to 1. That's not bad. Now we're within the 15 meter band. Let's bring in a marker. That's pretty good in 15 meters. 1.19 to 1 is our lowest SWR. In the 12 meter band, we're seeing an SWR low of 1.27 to 1. That's pretty good. All right, 10 meters. Looks like our low SWR in the 10 meter band is 1.36 to 1. So our loop is good from 30 meters up to 10 meters. We got more than we bargained for, but definitely we were well within our design specs, so that's good. So operation. Let's take it out and play with it. Here's my portable setup with the loop. So in there, I've got my Yaesu FT817, a battery, my tablet. Here's the loop. Broke down for travel. Doesn't take a lot of space in your trunk. Tripod to put it on. We'll set her up. Okay, so I'm sitting out here with the loop on the table. Got a little tripod. There she sits. I'm going to turn it so we're perpendicular to the house, radiating north and south. Here's how you tune it up. So I've got the radio sitting on 20 meters. I'm going to take the tuning capacitor. I'm going to listen for a peak in the noise. That's it. So once I've found the peak in the noise, I'll kind of go back and forth and I'll kind of gauge the range and then pick the center. And then I'll come down here and I'll look for a signal. And when I find something, then I'll re-peak the loop. And then when I transmit, I'll look at the SWR indicator and I might just touch it just a bit until I see the lowest SWR. But that's pretty much how you tune it.
Clear sailing all the way through so far, over. Good. We had rain for the last 2 days, so I don't get time to clean anything. Well, Rex, I wish I could help you out with that heat problem there, but that's just a touch above my pay grade. Good to hear you as always, Rex. About a 5'8" over this direction. You take care of yourself. Have a great day.
QSB.
Feel free to give us a shout anytime. Clear November 9, Tango, Quebec Zoo. That's Rex in Indiana, member station. Kilo 5, Foxtrot Echo Lima. Looking for your check-in. Come now, please.
Kilo Bravo Niner Romeo Lima Whiskey.
Boy, there's a light one in there. Anybody hear that one? Alrighty, That station trying to check in just now. Try it one more time.
Kilo Bravo Niner Romeo Lima Whiskey. Kilo Bravo Niner Romeo Lima Whiskey. Over.
Maybe a Kilo Bravo 9. Just hang in there for a little bit. Don't give up. This band is liable to change, and we'll do our best to get you in here. Kilo 5, Foxtrot Echo Lima, looking for your check-in. Come now, please.
Well, they heard me anyway.
Clear Whiskey 7, Quebec Hotel Zoo, Martin in Arizona, member station. And I hear you, that QRP. I hear you still trying in there. Try it one more time.
Kilo Bravo Niner Romeo Lima Whiskey. Kilo Bravo Niner Romeo Lima Whiskey. Over.
Boy, I tell you what, still not enough to get you in here. I'm crossing my fingers that this man cooperates and smiles for us. I'm doing my best. Just hang in there. Kilo 5, Foxtrot Echo Lima, looking for your check-in. Come now, please.
Well, it's been sitting out here with the little Zactec whisper beacon on it. And the footprint's pretty good. I've got it oriented east to west, but as you can see from the map, we got all the way up to Alaska and all the way down to Australia. Wow. And that's with this little Zactec whisper beacon, which is running about 200 to 300 milliwatts. Now, one thing I wanted to show you with this guy, one of the design goals with this loop was for it to be lighter, so I could do this. And it's pretty light. I'm holding it out at arm's length, and it doesn't weigh much. I could easily put my elbow against my waist and walk around with this, with the radio in a pouch. Pedestrian mobile. That was one of the design goals for this guy, was to have a light enough weight loop. And you can see it's so light I can easily hold it out like that. And I'm not as strong as I was last year. I'm still recovering, but yeah, pedestrian mobile. It'll be fun. That'll be in another video. There's my shadow. You can see walking along with a magnetic loop, taking a stroll, making contacts. Wouldn't that be fun? Well, the little loop kind of works. Well, it's been a comedy of errors these last 4 or 5 days that I've been trying to film a contact, and it's either been way too windy to be outside. It's two of the days we had winds of around 30 miles an hour with gusts, and there was just no way. Even if I could get the loop to stand up and sitting out there in it, all you'd hear on the camera would be wind noise. It was horrible. And the other 3 days in between there, including this morning, band conditions were just terrible. As you saw, they could barely hear me on the YL system, but they did hear me. It's definitely getting out. It's just band conditions have been bad and wind's been bad. I've been wanting to film a good contact for the video. That's why I've been waiting, but I've got to get this video out. So I'm not done with the little loop sitting back here. I'm going to build the capacitor into a box. I'm going to fiddle around with the coupling loop, maybe try a bigger diameter coupling loop, see if I can get it to be any more efficient. I've got an idea for what to use for the coupling loop that's, I think, kind of interesting. Somebody's probably going to get a chuckle out of. Yeah, so there'll be a part 3. I'll be refining the loop, trying to improve its efficiency. I think its bandwidth right now, I was measuring it somewhere in the range of around 30 to 40 kilohertz, which is way too wide. That means it's lower Q than it should be. With a magnetic loop, they're usually, if they're efficient, very, very high Q and very narrow bandwidth, on the order of 4 to 5 kilohertz bandwidth on a good loop like the Chameleon P2 I have, or another one that I've built in the past. And this one was seeing a bandwidth of 30 to 40 kilohertz, so I need to refine it some. So anyway, it's built. There you go. Build one yourself if you want. They're easy to put together. And you'll see this one in part 3 somewhere in the near future after I make some refinements to it. But in the meantime, take care and we'll see you in the next video. Thanks for watching. If you enjoyed the video, don't forget to give it a thumbs up. Also, if you're not already a subscriber, click to subscribe. Join us on the Facebook channel for discussion about the videos. And if you'd like to help support this channel, please click to support me on my Patreon page.